All right, hi guys, I'm Theo, I'm an Android engineer here at Capital One. And I'll be talking to you today about mocking your backend APIs through the development lifecycle. So, if I turn this on, it might help. There we go. All right, so I'll be going through a few things today. First is the problem that we're faced dealing with our backend APIs. Secondly, I'll go over what's the solution. Might have been spoiled by the title. I'll then go over a few different approaches that you could use to actually implement this within your own apps, and then talk a little bit about what we're doing here at Capital One. But before we go into that, let's just have some questions from the audience, if we just do this as a poll by raising hands. Who here has some hidden features within your apps that you only show based off of some backend response? Okay, yeah, a fair few of you. And then who has some sort of development environment that you use internally only, kind of for dev testing, stuff like that? Yeah, okay, most of you. And then from you guys, who shares that with the teams that develop your backend services? Okay, less of you, still some. And then who's actually ever had to deal with downtime on those dev environments while developing stuff? Yeah, we have that problem quite a lot. And then last question for you guys. So who is 100% happy with how you deal with your backend while developing an app? Yeah, not a single hand. That's good. I've not done this all in vain then. So some problems that we've kind of faced here at Capital One. The first is, of course, downtime. It's bound to happen, right? If you have a lot of different teams working on different services, something's going to break eventually during dev. Also, synchronization can sometimes be a bit of an issue. We'll get a bit of app work. The APIs aren't quite finished yet. The contracts might not have been formalized. And then app states. This might not be something that affects everyone, but we have a lot of different states in our app. They depend on a lot of different backend responses to get into them. It can be quite challenging sometimes to just manage the connections that you need between those. So what's the solution? It's, surprise, surprise, just to mock our backend. So before we go into actually the different approaches that we can use, I'll just give a bit of background information that we need. We've set up a to-do list app for this. It's a really simple to-do list app. It does one thing, keep track of your to-dos. So we've called it One List. And then One List just consists of our login screen and a to-do list screen. And as part of this, we'll be running a bit of an A/B test. So we have a new updated UI that we want to see how that works with users. You have a little floating action button, and then you have some separation between your items still to do and what you've already done. And that's pretty much it. Just quickly going over the module structure, this will be something most of you are used to already. We have our app module that contains kind of your manifest, various other things like that. Those then depend on your feature layers, your feature modules, sorry. So that has all of our UI code, your view models, if you use MVVM, and then all of your UI codes, whether it's in XML fragments or your composables. We then go on to our domain modules. This is where the core business logic of our app lives. And then we get to data. So there's a few modules here. We first have our API modules. So these contain, in our case, we use the repository pattern. So we have all of our interfaces defining our repositories here. And then we have those implementation modules of the APIs, where you have your concrete classes that go and will make API calls or hit a room database, for example. And it's quite important to note here that nothing actually depends on these implementation modules other than our app module. So just moving on to very quick run through of the app flow, you don't actually need to read through any of the code here. When you press the login button, we call a method in the view model. That then goes down to our use case. That then delegates over to a repository, which goes and makes our API call, fetches the user when you log in. It's fairly kind of standard stuff. And then before we navigate over to our final screen, we need to do one final check of, are we going to show people the new UI or the old UI? In this case, it's governed by a use case called the Speaking at Android use case. And the criteria is if your name's Theo or if you're born after the turn of the millennia, you get to see our nice new UI. Otherwise, sorry, you're going to be stuck with the old one for now. And then that's pretty much it for kind of the backend information we need, background information we need. So moving on to our first approach, that will be to fake our data layer. So we've just had a look now at the modules. So for our user part of our data layer, we have our user API and our implementation. What we're going to do now is just add another module on, which is our fake implementation. And it's a fairly simple module. It consists of one class. That's our fake user repository. It implements the same user repository that our normal one will do. And then we just have some predefined responses for what we want our users to look like. So this will just match off of our username. If the username is Theo, you'll get the user that gets our new UI. If you want to check your states of login for when incorrect credentials are passed, you can pass in the invalid username. And then everything else, just as a catch-all, takes you to your normal screen. So you might be wondering at this point then, how do we actually know when do we want to use our real repository that makes our network calls? When do we want to use that fake one? Anyone kind of have any ideas?
Build variants.
Build variants, exactly. Or product flavors, as we call them here. So this is something hopefully a lot of you will kind of be familiar with. We have an enum class that lives inside of a Gradle plugin. And most commonly, you'll see something that looks like this, where you have your dev flavor and you have your prod flavor. And both of those will contain a base URL that points to your different services. I've now added one flavor for each of the approaches we're going to look at today. I've hidden them out just so I don't ruin the surprise for the rest of the talk. The first one we'll be looking at is our fake flavor. And we can see here there isn't actually a URL needed here because we're not making any API calls. It's just not really necessary. So the reason why I've specifically specified we need to put this inside of a convention plugin is that gets pre-compiled before the rest of your Gradle syncs, which gives us these nice handy functions here that we can use to define different implementations for your different build flavors. So here we have our fake implementation using our fake user repository. And then for every other flavor that we have, we'll just use the normal repository. And then, so moving over to something like fake debug, fake release, whatever other sort of build variants you have using that fake flavor, it will then just pull in the correct classes into Hill, and then that gets injected everywhere else you need it. And then that's it. It's hopefully fairly simple stuff. Moving on to our second approach, we have using HTTP interceptors. So bringing in our second flavor here, we have a URL here. It doesn't really matter what because we're going to catch all of these requests before they go out. And then in this project, we're using retrofit. Most HTTP clients that you'll use, this uses OK HTTP under hood. Most of them will have some sort of support for interceptors. And this is kind of the standard setup you get. You'll set up our retrofit object using that base URL that you get from the build variant. And then we have this interceptor interface provided to us from OK HTTP. So we can come and create our response interceptor. And what this is going to do, in our case, we only have two endpoints. We have the user and the to-do endpoints. And there's not really too much complexity with this. So we can just match based off of the end of the path. If it ends with user, we're hitting our user endpoint. So we're just going to return a 200 OK. And it will have some pre-bundled user string, like JSON string, containing the user that we want as a response. And then coming back to our retrofit configuration, we can inject that interceptor. And then by the time, if we come to check our build flavor and it's our interceptor flavor, then we're going to add that interceptor into our client. Otherwise, it just gets skipped. And then that's pretty much it. You'll see kind of the common ground with all of these is they're all fairly simple implementations to actually get something running. Final approach that we'll kind of cover is using mock servers. So here we're actually going to use a real web server that returns real responses. They just might not be your actual services containing business logic. We might have some sort of logic if we want to branch between responses. It might just be a set of pre-bundled responses that gives you a singular flow through your app. So we have our third and final flavor here, which is mock. This is pointing, in our case here, to port 8899 on localhost. So in this scenario, you'll have your app tethered to your development machine. Your development machine is running on that port, and then any requests that you make will just go through to that mock server. There's various products that you could use for a mock server. You can use something off the shelf, and this is something like WireMock, mock server, rest assured. There's lots of stuff out on the market if you want to use something like this. Most of them are free and open source. You could use a copy of your local services. So if you're provided a Docker image containing those services, if you have access to the code, you can go and run that from your IDE. You may just put a database running locally, fill it with some sample data, and then you can use those. Or if neither of these really fit your need, you can go for a fully custom solution if you need to have some finer tweaks to work properly with your app. So that's it for mock servers. Nothing else actually has to happen in your app. It's still using your real implementations the whole through. It's still using your HTTP client as expected. So you might be saying now, well, which approach is actually best for me? And I don't know your apps at all, really. I definitely don't know what your code bases look like. And the reality is everyone's going to have a slightly different set of needs. So there's no one solution fits all. What I can do, though, is just go over some pros and cons. So we'll go first to faking the data layer. Out of curiosity, does anyone currently use this method within their apps? Okay, a couple of you. So some pros of this are you get to organize all of your data quite nicely. Anything related to our user repository is going to sit within that implementation module. It's nice and easy to find that data. It also decouples it from the contract of your APIs. So if you're in a scenario where you have a lot of change through those, you don't quite know what those are going to look like yet, you can still build out your repository, you can still get some data from that without having to have that, whether it's REST or GraphQL or anything, that contract doesn't need to yet exist. And it's also really handy for third-party SDKs because it means anything that you would normally be bringing in, you can just leave out as part of this build variant. You don't have to bring it into your class path. It's quicker compile times, less things to worry about if you just want to test your business logic. Some cons of it are, though, it's not end-to-end. At the end of the day, you are still using a fake repository. If you have some holes, any small bugs within your real implementation, if you do the majority of the testing in this scenario, you probably won't find those unless you've happened to have the same bug in both implementations. It's also not that flexible. Because we just have all of that pre-bundled response, you either end up with a very complex repository in order to handle your different cases, or you have to go into your app and change something, and that's lots of recompilations. If you have a large app, if it's not yet modularized or you're still on the way, that could be quite a lot of time just sitting around waiting and, okay, fine, when's it going to compile? I've definitely been one of those people just sitting there. I imagine a lot of you have as well. And then it slightly complicates our dependency tree as well. We now have to think about, okay, which modules are actually going to be included in this bundled APK that we have. It's not too bad because you have those build variants to help, but it's still something to think about. Moving on then to the HTTP interceptors, is there anyone who uses this method within their apps? Okay, a couple of you. So just quickly running through the pros and cons. This is actually end-to-end. You're going to be using your real repositories all the way through up to your feature layer. It's also quite simple to set up. We run through it in, 30 seconds, a minute. We could get through everything we needed to just get the basic setup. But some of the cons are that interceptor can get big. If you have a lot of endpoints that you rely on within your app, you might end up with a very large interceptor, or you could have lots of smaller interceptors, but then you have to worry about missing anything if it's split up because it has to pass through all of that chain. And again, as before, it's not that flexible for testing. If you have some pre-bundled responses, you either have to change an asset or change some code. Again, leads to lots of recompilations. We try and avoid that where we can. Moving then on to mock servers. I'm expecting hopefully to see some more hands here. Okay, a few more. Still not a massive amount. So some pros are, again, you're using end-to-end, but this time it's a lot more flexible. Because that mock server is not actually included within our application, we can make changes to that without having to rebuild or even necessarily relaunch our app. It's also great for tests because you can just interface with it the same way you normally would if you have to change anything. But some cons are, for a lot of the solutions, you need to be tethered to a development machine. You can't just have a standalone device. And it adds a bit of complexity in the fact that you have now another component that you have to manage within your landscape. So that brings us on quite nicely to what we're doing at Capital One. For a long time, we were using the interceptor method I spoke about, and we ran into all of these problems of very large interceptor, a lot of compile times if we need to change responses, and just difficulty tracking what we actually need to change. So we've moved on to a solution we've called Local API. Now what Local API is it's a web server. It serves some pre-configured responses that we have. We pass in a file tree or a zip containing all of our responses with some specs about what endpoint they relate to. It's written in Kotlin multi-platform, and it targets the JVM platform, meaning you can run it on your development machines. And it also targets Android and iOS, meaning you can run it bundled on device. You don't actually have to be tethered to any sort of machine if you still want to have a dynamic server. We have dynamic responses, meaning you can supply multiple different responses for any given endpoint. And if you want to change out those responses, we've exposed a REST API, which will allow you to send a request saying, hey, for this endpoint, actually, we want to now use this new response instead. And if you're running on the JVM, you have hot reloading available. So it means you can just go in, physically change something within the file, and the next time you make a request to that endpoint, you get the new data back. And then finally, we have request validation. So any of our requests that come in, you can define a spec saying, this is the structure we expect for our headers, this is the structure we expect for our body. And so if we come and we make a request from our app that doesn't match that, it's going to fail. It's going to send back some invalid response. So it will help us catch really early on if something's gone wrong, if a contract has changed somewhere in the app, that we're actually sending the wrong data to our services. So is it actually worth the trouble? Because it is a little bit of trouble to get something like this set up, especially from scratch. Just going into why we went custom, we have a lot of different states within our app. Here's 3 examples of many of what the landing page could look like in our app. The first one on the left here is what the majority of our customers will see. This will just be your standard account. The image in the middle is for what we call our collections customers. So these are customers who are behind on their payments. They might need a little bit of help. They might need a bit of a nudge to bring their account back up to date. And then on the right is something I hope no one really has to experience, but this is for our defaulted customers. So this means their account has unfortunately had to be closed, the card has been freezed, and this is giving them some information basically on what they need to do next. To get into these states requires a combination of responses from 3 different endpoints. So when we're coming, if we're testing on our live environment, we need to have an account that's properly conditioned. If we're testing with the interceptors, we need to know exactly which files to change and what to change. It became quite a burden to do all of these changes. So with Local API now, because it runs on device, we can just take a phone that has Local API on it. It has our app on it that's configured to point requests to here. And we've given it a small floating window UI that allows you to configure those responses. So you can then go and hand this to someone who works in product management or one of your UI designers or a business analyst. And where before they would have to come to us and we'd sit down and take them through a demo of the app, you can now just give it to them and they're free to explore. They can get into whatever states they want. A few examples of this are, so this is what we were just talking about before of our different landing pages. When we just come and log in here now, we get our standard state. And then once we log out, where before this would have required a recompilation, 5 to 10 minutes of waiting, we can now just open that floating window and change some responses. I've had to blur them out because it contains actual details of our endpoints, which unfortunately we can't share. But then once we change that and log in, within 20 seconds, we're on that new state. Another helpful example is if we're seeing our transactions and we want to see, well, what does our app look like if it's a fresh account, you've never made any payments on this card before. Again, it's a simple change, exit out, refresh, and we get that state that we need to. If we need to go back, you just open it again, reset all, refresh, and we come back to our fully populated state. Now, this 20-second clip, again, I'm going to repeat myself a few times here, but this would have been 2 recompilations in our app to go from one to the other and back again. It's a lot of wasted time for you. It's a lot of wasted time for everyone else involved. Final example I'll run through here is some of you may or may not know that we actually host cards for different brands. So on top of Capital One, the Post Office credit card, or Think Money, or Ocean Finance, for example, they all run off of our app, off of our technology. It's just a different card, a different brand. So we can, again, come in, just change a request. It's one request for the partner brand. We log in again, and then we get to see our fairly recently launched ASOS credit card with all of the new theming on there. So just to quickly summarize why this was worth the trouble for us, I appreciate a lot of people might not need to go into this much depth, but if you do, this was a godsend for us. It meant we had a single source of truth for all of our mocks. We could use it in development, we could use it in testing. It increases our development speeds drastically. It improves our testing capabilities because we no longer have to worry about, well, what are our backend services doing if we need to test the scenario. And it gives us much easier access into all of our different states. So thank you all for your attention. I'd like to open the floor to anyone if they have any questions. And yeah.